I'm smarter than noggin.
In the noggin. Alright, functions is what we're talking about today. Functions have been around for you since Algebra 1. So, won't be anything, you're out over there, anything too hard for us. I haven't had this thing on in a while, so it came up looking crazy. Alright, if I gave us this set of ordered pair, got my braces that my set of ordered pairs in, it's got a 0, 3, a negative 1, 2, and a negative 1, 3. Okay? Now, that's a relation. Okay, so we got some definitions that we have to go over as we're talking about this today. A relation is just a set of ordered pairs. That's all it means. So you got a set of ordered pairs there. That's a relation. The question is that relation a function? Okay, definition of a function. There's some fancy technical math terms. Let's see if I can read you a correct definition before I give you my words. Here it is. A function is a relation in which, for each value of the first component of the ordered pairs, there's exactly one value of the second component. What that means is that an x cannot be repeated in the relation. So x can only go with one number. So if I'm looking at this and asking you if it's a function or not, I look here and I say, all right, 0 goes with 3. Does 0 go with 2? No. Does 0 go with that 3? No. So far so good. Now I get to negative 1. Negative 1 is supposed to go with 2. It can't go with anything else. Oh, here negative 1 goes with 3. So I've got a negative 1 in the x spot twice, which means that is not a function. X's can't be repeated. Y's don't matter when you're checking for a function. It's all about the x's. All my x's live in
Texas.
That's the second time we've What did you say? Was that one? Alright, here I have set of ordered pairs, so I've got a relation. Is this, fellas, is this relation a function?
Yes.
Zane said yes, Kaylee said yes, Baylor, Hayden, what do y'all think? Y'all got it? Is that second one with the 5s, the 4s, and the 6s, is that a function? Had a couple of yeses, anybody?
Yes.
Okay, good. Reason, it is yes. Y'all are correct. Everybody had it right on that. Reason, it is yes. 5 goes with 4, 6 goes with 4, 7 goes with 4. The 6 doesn't go with anything else. 7 doesn't go with anything else. When we looked at these in Algebra 2, we looked at what's called a mapping. Okay, so I'm going to go up here to this first relation. I'm going to put that in a mapping. It's when we have an x oval and a y oval. So I'm going to put my x's in here, 0, negative 1. Then I'm going to put my y's over here, 3, 2. Okay.
I remember that.
Good, Mason. 0 goes with 3. Negative 1 goes with 2. Negative 1 also goes with 3. So if I look at it from the mapping, I see I got 2 arrows coming out of my x. That can't happen. X's can only be used once. Now this one, if I go to my mapping on that second one, I've got a 5, a 6, and a 7 in the x. My y's are all 4s. The 5 goes with 4, the 6 goes with 4, the 7 goes with 4. So the 4 is getting a lot of attention, but none of these 5, 6, or 7s over here have 2 arrows, do they? So this one again is a no, this one is your yes. Okay, what we're going to be asked to add on to this lesson today is to talk about domain and range. You know this already. The domain and the range, that's x's and y's. Which one is which? Domain is the x, good Chase, range is the y. I remember it because it's alphabetical. X comes before y, D comes before R, so it matches up alphabetical. Every relation has a domain and a range, even if it's not a function. So this number 1 up here that we did, the domain of that would be 0 and negative 1. That's everything that's in the x's, right? The range would be 3 and 2, everything that's in the y's. Okay, so if you're asked to talk about domain and range, though, that's what you do. I had some that repeated. I didn't write them twice. Do I need to? Why didn't I write -1 twice on the domain on that first one?
Because, I mean, it's already there once.
Right.
So what's the point?
Good. I could if I wanted to. I could write 0, -1, -1, but I don't like to waste all that smartboard ink, so I saved some steps on that.
Yeah.
Yeah.
That smartboard is expensive now.
I know it.
Nowadays.
I know it. Alright. I gave you a set of ordered pair on that. I could give you a table. Let's look here at this table. Come on, you. I got my years, and they're going to start at 1999, and they're going to go to 2004. Then over here, I've got some numbers. 86,047, 109,478, 128,375, 140,767, 158,722, 182,000, and 140. Guys, y'all pay attention, please. All right, what we got here, it says that this is the, where did we go? There we go. This is the relationship represented by cellular telephone subscribers in that year. Okay, so what this is telling us, and this is in 1999, 86,047 people had a cell phone. In 2000, 109,478 people had a cell phone. In 2001, so on and so forth. So you see, obviously, the amount of people that have cell phones increasing. Before that, nobody had them. They had landlines. The early 90s when cell phones came out, late 80s maybe. The question asks, is this a function?
Yeah.
Mason thinks yeah. Chase concurs. What does everybody else think? How can I know for sure? Dustin concurs? Good. We don't see any year repeating in there. And how could, if we put this problem into context, how could a year repeat? If I said if the data, the research showed us in 2002, 140,776 people had a cell phone, could you then say 2002, 200 people had a cell phone?
Nope.
No, you can't. I mean, that it goes with that. There's no way you could change it, right? So yes, that would be a function. Now, what would my domain be? Which one of these represents the domain? Good. It's the years. And people always get confused when they see a table like that, because if I had labeled this up here, this would have said years, this would have said cell phone customers, and they're like, well, I don't know which one's the X and the Y. Well, an input-output table is X, Y. So if you had to write out your domain, you would just start listing out those years. Okay? Not going to make you list out all the Y's, the ranges, because that would be lots of numbers to write. Alright. Got a graph. We've looked at a set of word pairs. We looked at a table. Now we're going to look at a graph or a few. My page will turn. I didn't pick that. I want my page to turn. There we go. Let's put a piece of graph paper in there. Alright, let's say we had a graph that looks something like this. Guys, y'all pay attention. The question asks a couple of things. Tell if it's a function and give the domain and range. Alright, what do you think about the function answer?
Yes.
Mason thinks yes. Anybody else? How could we know for sure?
Well,
Other than Mason's just a genius, because he is.
look on the x-axis.
Okay? We're going to pick a point out like Kaylee's talking about. If I wanted to check the x of 2, I come over here to 2. When x is 2, my y is approximately 2. I can round that and say that's really close to 2. It's a little more, but it'll be approximately 2. On 2, on the x-axis, does it hit anywhere else except for right there? No, there's no other y value that goes with that. So what if I wanted to pick -3? -1, 2, 3. Y has to be approximately 1.5, right? There's nothing else. It doesn't hit anything else. So that's good. That's a good way to check that. So I'm saying yes. There was another thing that we did in Algebra 2 and Algebra 1 to check a graph to see if it's a function. Anybody remember?
The slope.
Close. Close. It's a test. It's got a name that's a test. Remember?
I remember it, but I don't remember it. I remember you doing something around there. I just don't remember how to do it. I bet you don't remember it at all. I mean, I've been in this class
But you don't
twice now.
How about pick it? How about a vertical line test?
That's what I.
If we put a vertical line on that graph and move it left or right like you read a book, is it ever going to touch my vertical line more than once at any spot?
Nope.
Nope. So it would pass the vertical line test, which would mean yes, it's a function. Some people in first period remember I called it the pencil test because I told you you could put your pencil on your paper and move it left or right. Y'all remember doing that? Maybe Chase does. All right. So let's look at a few more that we can do a vertical line test on. I'm just going to draw some random graphs for you. Use the fancy drawer to draw a couple. I like that one. Oh, didn't pick some paint up there, it looks like. Okay, I want to go draw one of these dudes. Okay, I want to go draw these dudes. And then I want to draw one of those dudes. Alright, so 1, 2, 3, 4. I got 4 different graphs that we're going to look at. What do you think about that oval? Is that going to pass my vertical line test?
Absolutely not.
Obviously, a big fat no on that one. If I dropped a vertical line right there, it's obviously touching it twice. 1, 2. So that one is not a function. Okay, now move over here to this line. What about that line? Would that pass the vertical line test?
Yeah.
Yes, and we're going to talk about that for just a second, if this will ever pick me in a line up there. There we go. If I drop my vertical line there, yeah, it only touches it once. So yes, that is a function. Every line, with the exception of one type, will pass the vertical line test. What type of line will not pass the vertical line test?
Vertical.
A vertical line, very good. Because if we had a vertical line, where my stuff is going nonsense, and we put another vertical line right over it, it's touching it all up and down it, right?
Yeah.
Infinite many times. So every line except for a vertical line is a function. Okay, now I'm going to try, see if I can just drag that vertical line over here to my parabola. What about a parabola?
Nope.
Why?
Yeah.
Because it touches on the little.
Okay, that's what we're going to talk about. It is yes.
Oh.
But Mason's argument is a very common one, and I understand it.
It's because it's always kind of going.
Right. Right, Hayden. Hayden remembers that even though it may not be drastic, these sides are always going out.
Okay.
So even though I chose a big old fat vertical line and that was poor on my choice, it would keep going out, so it really wouldn't touch it. So a normal parabola like this or an upside down parabola, either one would yes be a function. Okay, now let's see if we can take our line over there to that sideways parabola. What about a sideways parabola? That's a never, a no on that. Good job. Not a kid. Alright, vertical line test. Now we've done a table, we've done a set of ordered pair, we've done a graph. Sometimes the hardest ones for people to decide on are equations. So let's look at some equations and decide if they're functions or not. First one I've got says y equals negative 2x plus 7. Question wants to know, Is that a function and give the domain? Is that a function and give the domain? Any thoughts on how we can figure that out?
We could graph it.
Okay, that's an easy thing to do. I like that. And don't forget also, this one I don't need to, but I can always graph it in my calculator and look at a picture on my calculator and visualize the vertical line test. We had to talk about that first period. This one I don't need to. It's real easy. We've been doing this all week. It's got a y-intercept of 7 and a slope of -2. So I know it's going to be a line looking something like that, right? And what did we say about any diagonal line? Is it a function?
Yeah.
Yes. Okay. Domain. Domain stood for x's or y's? X. Is this thing ever going to stop going to the left? No. So the domain will be negative infinity. Is it ever going to stop going to the right?
Negative.
Nope. So it'll be infinity. So that would be our domain. Every line that will be true except for a vertical one, because the vertical one doesn't go left or right. All right, how about square root of, let me write it all, y equals the square root of 5x minus 6. Shh, y'all simmer down. Is that a function and give the domain? How could we find out? Okay, so grab your calculator. Let's hit y equals, that very top row right underneath the screen is your graphing menu. Hit y equals second square root 5x minus 6. Hit graph. Okay, everybody get a graph that looks similar to that? Well, maybe not, but something like that.
Yeah.
Okay, so we do a vertical line test on that. Will that pass the vertical line test?
Yes.
Yes, it is a function. One thing that always helps me remember what the square root graph will look like, we know a squared graph looks like a parabola. It is a parabola, right? If something's squared, it's a parabola. So if you're doing the square root, you're undoing that parabola. So this thing right here is actually half a parabola.
Oh, that makes sense.
So if you, whoops, it's starting to jump. See, you could draw that other half there, right? So you know that a half of a parabola like that will be a function. All right, the domain on this one's a little bit tricky. It's not negative infinity to infinity like we've been seeing. When you got a square root, what kind of number can you not have underneath that radical?
Negative.
Negative, very good. So what we got to do, Mason, let's quit moving that around, is take what's underneath there, and we got to make sure it's not negative, so it has to be greater than or equal to 0. Okay? So what would our first step here be to solve for x? So 5x is greater than or equal to 6, then what?
Divide by 5.
So my domain is what I just wrote there. That's my domain. X has to be greater than or equal to 6/5, because if it's not, I'm going to get a non-real solution. It would be imaginary, which we remember from Algebra 2, and we'll get to a little bit later in here. So my domain has to be, that's all it's jumbled up there, greater than or equal to 6/5. All right, this next one I'm going to show you, you can't type in your calculator. So we're going to have some knowledge about graphs on this one. It says y to the 4th, maybe.
Thing still messing up?
Y to the 4th is equal to x. Alright, just ignore the nonsense up there. Y to the 4th is equal to x. Now the reason you can't type that in like it says is because your graphing menu works in terms of y. It's got to be solved for y. This is not solved for y. We could solve it for y. That would be an option if you wanted to do that. But do we know enough about this? What do y'all think? I mean, I know y'all aren't following me. Obviously, you're staring at me. Any thoughts on what we could do other than solve it for y? No?
Do the root of it with the 4.
Okay, that would be solving it for y. We could do that. Is that just what y'all want to try?
Yeah, go ahead.
Okay, undo that 4th power with what Grace said would be the 4th root. So y would equal the 4th root of x. Is that right? Okay. Do you know how to do that in your calculator?
No.
Let's do it together. We'll get y equals again. Y equals, to get that fourth root, you got to hit the 4 first. If the root's bigger than 3, you got to push the number first. So when y equals, I'm going to hit 4. Then I'm going to hit math. And I'm going to move it down to number 5, where it has the x out there. Pick that. Now I can type in my x and hit graph. This one, the zoom is weird. Rachel should have told me the zoom was weird. Zoom 6, she didn't care work for her. Alright, so it almost, on this poor resolution, low pixel stuff, almost looks linear. Is it? No, because it's a fourth power. Fourth power is not linear. So what do you think about a vertical line test on that?
It would pass.
It would pass easy. Even though the graph is poor, you ought to be able to tell. If we're debating right here, a vertical line test, that's just going to hit it once anywhere, right?
Yep.
So Zane is exactamundo. Yes, that is a function. What about the domain? Look at your picture on your calculator. It keeps going to the right forever, but it doesn't go to the left forever. So I wonder how far it goes to the left. Could I look at my table? You know how to go to your table? Hit second table.
Where's the
Right up on the very top on the graph button. Look at -1 in the x. What does it say?
error?
Error. Why?
Because it's not there.
Yeah. What he said.
Dude, you really just did that? No, it wasn't me.
I remember talking about that. Think so? I don't think so. I think in some cases maybe.
This
but-
is
Like I know, like when I got my head tested,
Dude.
I didn't know it was shit. But when I broke my arm in 5 different places,
Look up how long the route
That-
It's
Right.
Yes.
It worked.
For y'all.
Alright, we were looking at the domain. I had you in your table. Hey, focus. Had you in your table looking at the domain. At -1, it said the y was an error.
Because it's not there.
Because it didn't go past that. But at 0, what was the y? That's okay, right?
Yes.
So my domain, if the x is 0, it's okay. If the x is -1, it's not okay. So my domain for this, I can say x has to be greater than or equal to 0. That's it. Pretty good. Alright, what about, you remember the stuff we graphed yesterday? Oh my goodness, Chase. Let's remember yesterday we graphed something that might have looked like this, right?
Yep.
That would have came from, let me see if I can make up an equation that would work for that real fast. Y is less than or equal to -2x plus 3. Okay, I think I did pretty good. That would have a y-intercept of 3, have a slope of -2, right?
Yep.
Okay, so would that pass the vertical line test?
Yes.
No.
Wow.
It's vertical.
Oh.
If I drew a vertical line, all this shading is touching the vertical line, right?
That's confusing.
Everything that's scribbled is touching the vertical line. So yeah, it only actually touches there one time, but it's touching here, 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 all in that shaded, right? So that means if we see something like that, it's not going to be a function. Okay? Domain's still easy on the line because it's going to go left forever. It's going to go right forever, so the domain would still be negative infinity to infinity.
That was some great.
Whatever
Oh,
that's
no.
less than or greater than. Fine without.
It would still be the same because if that had been the case, the shading would have been on top. Anytime there's shading, it's going to hit your vertical line a bunch of times.
Okay.
All right, this next phase that the unit takes us to is pretty simple. This was some of the stuff that Miss Ladou's Algebra 3 class was going on. There's another Algebra 3 teacher this year. Some people in first period got Miss Ladou.
Where's your class?
In between Campbell and Stewart. But I kind of laughed at them because this is easy and they didn't know what to do. But it says f of x equals negative 3x plus 5 over 2. All right, first off, guys, y'all focus. First off, we know this is a function without even having to do a test or look at a graph or anything because it's written in function notation. What about that says function notation? F of x. Very good. So I don't even got a test on that. What we're going to do is two things. We're going to first off solve for f of 2. Then we're going to solve for f of a. All right? So if they ask me to solve for f of 2, all I got to do is take a 2, put it in the x spot, and evaluate. So pretty simple stuff on this. F of 2 would equal negative 3 times 2. I put the 2 in the x spot, plus 5 divided by 2. Okay, y'all will all be able to handle that real quick. You got it? Negative 6. Negative 6 plus 5 is negative 1. So negative 1/2 would be my f of 2. Now, one of the things that they were confused on in Miss Ladou's class that they were asking me about was how did you do f of a? That's even easier because there's not even any calculations to do. You're just going to plug an a in for the x. So we would say f of a is equal to negative 3a plus 5 divided by 2.
That's your answer.
Uh-huh. So we didn't even we just had to rewrite it. Didn't even have to really do anything.
This stuff is easy.
I
Please
think
tell
so,
me it doesn't
too.
get harder.
It's pretty good, pretty good.
Hey, is that a real knife?
No, it's a plastic training sword. It's pretty heavy though. It would still hurt if you whacked somebody with it.
My
But it-
stepdad's got a real one, and it's really heavy. It's like
I hit
almost
Baylor
100
with
pounds.
it.
No, I don't
You
want to hurt
won't.
Bailey.
He's not shutting up today.
Alright, so I've got g of x, so it's still a function, even though they changed it to g, that's still function notation. This time, we're asked to solve for g of m plus 2. Whoa, we got a whole binomial we're evaluating for. G of m plus 2. So we have to take this whole binomial, plug it in that x. Makes you pay attention. So g of m plus 2 is 5 times m plus 2 minus 1. Distribute. Now I got one more step. What is it?
10 minus 1.
Attaboy. So we got 5m plus 9. And that's all. That's all we had to do on that. Got a few more, couple more types. I got what we need on that? Good, Caleb, good. Very. Alright, this one I've got a table that has an f, an x, and an f of x. In my table I've got negative 4, negative 2, 0, 2, 4, 16, 4, 0, 4, 16. That's the first one we're going to work. The second one, I've got a set of ordered pair. The function is equal to 2, 6, 4, 2. And then number 3, f of x is equal to negative x squared. Alright, We are going to evaluate all three of those problems. That's three different problems there. The table's number 1, the set of ordered pairs number 2, and the equations number 3. We're going to evaluate all three of those for f of 2. Better pay attention. F of 2. Okay? This is about, on the table, as easy as it can be, and this is one of the things that kid out of Ladou's class was asking about. F of 2. Go to the number 1 with the table. Find your x of 2. What is our answer?
2.
So out of that table, f of 2 is equal to 4. We just found its match. Okay?
Oh, okay. Yeah.
Good. Up here in the ordered pair. Up here in the ordered set of ordered pair. Everybody up there on number 2? What is the match of f of 2?
4.
6. Because it's where the x is 2. That's why I chose that one, because that one is a little bit tricky because it's got it in there twice. But it's where the x is 2, and it goes with 6. So that one would be 6. Now nobody, well, I'll take that back. I think there was one kid in first period got the third one right. First off, what are we going to do in the third one? Good, good, Zane, good, Kettle. We're going to plug that 2 in, right? That was a struggle first period. They were like, I don't know, it's x. And I'm like, we've already done a problem like that. You plug the 2 in. But the way this is written is odd. Okay, that means we're going to, when there's, the negative is not in the parentheses, that means we're going to take the opposite of our number squared. It doesn't mean we're squaring the negative. Okay, remember how we talked about that before? 2 squared is 4, and then we take the opposite of that. I had a lot of people tell me 4 this morning instead of negative 4. Alright, next page. We ready, Freddie? Here I've got x squared minus 4y equals 3. Directions say rewrite the equation using function notation f of x, then find f of 1 and f of a. So we have 3 things to do, Hayden. We got to rewrite it. Keep your hands to yourself, guys. Rewrite it in function notation, number 1. Then once we do, solve it for 1 and then solve it for a. Alright, so in this equation that we have, which of these variables is the same as f of x?
The y.
Very good, Zane. So if we can solve this thing for y, we'll have it in function notation, right? So what would my first job be in getting the y all by itself? Subtract x squared. So I'm going to write that as negative 4y. And I like my x to go first, so I'm going to put negative x squared plus 3. I still don't have the y all by itself. It's been, go ahead, Zane. Divide by negative 4 because it's being multiplied. So we got to divide everything by negative 4. Now that over here, that'll cancel out, leave me y, which is the same as f of x. So I'm there. Look at what I'm going to do here. I'm dividing both of these by negative 4, right? So right here where my mouse is, that negative divided by negative makes that a positive. This positive divided by a negative makes that a negative. Is that okay?
Yep.
Good, good. So there's my function notation, f of x. Now the second question I asked you was for f of 1. So you just got to plug a 1 in for that x and evaluate. You can do that pretty quickly. 1 squared is 1. 1 minus 3 is negative 2. What's negative 2 over 4?
Negative 1/2.
Negative 1/2. Okay, and then my last one's what looks confusing, but it's the easiest. All you do is switch the x for an a. So it'd be a squared minus 3 over 4. Okay? Pretty good stuff on that. Any problems with it? It's always something that I have to ask myself every time we start covering functions. Which one is it that can repeat and cannot? So I always have to remind myself. X's cannot repeat. Y's don't matter. Okay? Next week, we'll start with some assignments and some review stuff. And by the end of the week, we'll be having a test over all this linear stuff. Okay, remember we did a lot of graphing, a lot of different types of lines. So we'll be having a test over all that at the end of next week.
Do we have a...
No exit question today. We just got a couple of minutes. I know, I've just got a